So the chain rule is dy over dx equals to dy over dt times by dt over dx. So what this means is, for example, if we had this y equals to 4x plus 5 to the power of 6, to find dy over dx, we would split this up into y equals to t to the power of 6 and t equals to 4x plus 5. Now dy over dt equals 6t to the power of 5 and dt over dx equals to 4 from normal differentiating rules. So now we multiply both of these together, 4 times by 6t to the power of 5, which will simply be 24 times by 4x plus 5 to the power of 5. So this can be taken further. So if we're asked to find the gradient at a specific point on a curve, for example, to find the gradient when x equals to 2, what we would do would be substituting in 2, so 8 plus 5 to the power of 5, so 24 times by 13 to the power of 5. And the answer that we'd get from this would be the gradient at the point on the curve. So the gradient would be 24 times by 13 to the power of 5, so 8911032. That would be the gradient at this point when x equals to 2 on the curve. So another question that we can try is y equals to 6x squared plus 4x all to the power of 7. So y equals to t to the power of 7, where t equals to 6x squared plus 4x. dy over dt equals to 7t to the power of 6. dt over dx is 12x plus 4. And now we know to multiply this dt over dx by dy over dt by the chain rule. So you would get 6x squared plus 4x all to the power of 6. And from here we can be asked to find out the gradient at a specific point, or even to find stationary points. And by stationary points, what they mean is we must set dy equals to dy over dx equals to 0, and any corresponding x values would give the points on the curve where the gradient is 0. Now we can try another question. How about if we try this one in terms of e? So if we say y equals 4e to the power of t, and we know that t equals to cos of x, dy over dt would be 4e to the t, because by normal differentiation rules this would just be that, and dt over dx would be minus sine of x. And now we can multiply these both together to find dy over dx. So that would give us minus 4e to the power of cos of x, all multiplied by sine of x. Another question that you could be asked is to find out the derivative when a question is in the form x equals to, for example, y to the power of 4 plus 2y. So what you need to know for a question like this is that dy over dx is simply 1 over dx over dy. So we would find out dx over dy first, which we can do by normal differentiation rules. So 4y to the power of 3 plus 2. And then to find dy over dx, we know this would be 1 over 4y cubed plus 2. So what you've got to remember is, if we want 1 to be above, all we've got to do is find the reciprocal of our expression. So this can be useful when you're given a question in the form where you're not really used to the variable, and it can be also used more commonly in differential equations. So if we try another question now, y equals to sine of 6x, sine squared of 6x. So now what we can do, we know that y equals to sine of 6x squared. That's just the same as writing it as squared. So we know that y equals to t to the power of 2, where t is equal to sine of 6x. And by normal product rule, by normal chain rule, we can find out the derivative of this. So we know dy over dt will equal to 2t, and dt over dx will equal to 6 cos of 6x, and we just multiply them both together. So 2 times 6 will become 12, so we get 12 cos of 6x times by sine of 6x. So this is a bit of extension, but we know that using double angle formulae, we know that sine of 2a equals to sine of a cos of a. So if we take out 6 from here, then we've got 2 cos of 6x sine of 6x. So we know that this can be written as 6 times by sine of 12x, just if we wanted to simplify the answer. Another question that we can try is 3 times by x minus 7 all to the power of minus 3. We know that y equals 3t to the power of minus 3 and t equals to x minus 7. dy over dt minus 3 times 3 is just minus 9t to the power of minus 4. dt over dx is just 1. And we can multiply them to get minus 9 times by x minus 7 all to the power of minus 4.